Hello and welcome to Geometry Geometric Measurement Study Guide review. For this particular module, you are going to be relying heavily on your reference sheet. Some of the stuff is already going to be on there, but there are some things that isn't. So you'll want to include things like area of a kite, and some other things that we'll kind of go through and talk about as we go through the video. But you're definitely going to want to have your reference sheet out while you are practicing, while you are studying. You want to know what's on there and then what you need to add. All right, let's go ahead and get started with number one. For number one, it asks, what is the area of the parallelogram? Well, the area of a parallelogram is base times height, and we have a base, but we only have a slant height here. We don't have an actual height. The height is always going to be perpendicular to the base. So that's something that we need to find. We need to figure out what h is. And we have a right triangle because they give us that little piece there at the bottom, so I can go ahead and figure out what h is. So I've got a squared plus b squared equals c squared. My c is going to go across from that 90-degree angle, so that's going to be 25 squared. And then I have 7 squared plus h squared. 7 squared gives me 49 plus h squared, and then 25 squared is 625. Subtract 49 from both sides, and I get h squared is equal to 576. And then if I take the square root of both sides, I get h is equal to 24. So now I have the base and my height. So my base is 30 times my height, which is now 24. And so this is going to be 720 centimeters squared. For number two, it's asking us for the area of a kite. This is one of the things that you probably need to add to your reference sheet. We could kind of think of this as triangles, and so I would be able to, these are all 90 degrees by the way. This piece would be equal to this piece is equal to this piece. And so you want to kind of have something drawn like this on your reference sheet, and then area is equal to 1/2 times diameter 1 times diameter 2. So you're multiplying these two here. And that's something that you have to memorize. If they give you different information, you could use area of triangles to kind of help you out here. I just always remember that this is made up of triangles, and it kind of helps me remember the formula because the area of a triangle is 1/2 base times height. And so that's kind of how I think about these, and I kind of just think of this as a base and this as a height, even though that's not true. So we've got 1/2 times 30 times 15, and you can put that 1/2 in parentheses as well. Go ahead and type that whole thing in your calculator. 1/2 of 30 is 15, and then 15 times 15 is 225. And so the area of this kite is 225 inches squared. For number three, they're asking for the area of a trapezoid. The area of a trapezoid is on your reference sheet, and it has area equals 1/2 the height times the sum of the bases. And with a right trapezoid like this, this would be our height as it's perpendicular to our base. And so we already have that there. If not, you may have to find the height similar to what we did with number 1. So just kind of keep that in mind. All right, and so we've got 1/2 times 150, which is our height, and then we're going to add our two bases together, and our two bases are going to be these, our two parallel sides. And so it's going to be 150 plus 300, and I end up with 1/2 times 150 times 450. Go ahead and plug that whole thing in your calculator, and you should end up with 33,750. So 33,750 yards squared for the area of this trapezoid. Number 4 is a vocabulary question. It says there's a regular hexagon, A, B, C, D, E, F, inscribed in the circle. That just means it's inside the circle and those vertices are like touching that circle. All right, and then it says, what is HF? And if we look at HF, it's going from the center all the way to the point on that circle, and so that means it's a radius. So HF is a radius. And then we've got AF, and that's going to be a side of that pentagon. And we can see that all of these would be the sides, right? And then HG, that point right there, HG is called the apothem. And so when they start asking about find the area of a regular polygon, that is the piece that you're going to use with your reference sheet where it has A for the apothem. And so HG is your apothem. So when you kind of think about, let's say, and we'll just use a square as an example, your apothem, if you took and put like a circle around these, not even a circle, but if you're taking this and you're creating a right triangle out of it, right? This piece right here is called your apothem. So even if you have a pentagon, something like this, oh, that's ugly. If you create your triangles out of these, right? That height of that triangle that you just created going to the center is your apothem. And so that's how you can find the area of these. So just kind of keep that in mind. You need to know what an apothem is, and you need to be able to recognize it for your test and for your EOC. For number 5, it asks us to find the area of the shaded region. That means our shaded region, or the area of our shaded region, I should say, is equal to the rectangle and then minus that triangle. So the area of our rectangle is going to be base times height of the rectangle. And then we've got minus 1/2 times the base of the triangle times the height of the triangle. I don't want you to think that those B's and those H's are the same thing, because they're not. They're talking about of the rectangle and then of the triangle, so just be careful. All right, so the base of our rectangle is 25, and the height of our rectangle is 11. So that's 25 times 11 minus 1/2, and then the base of that triangle is 11, and then the height is 14. So that's going to be times 11 times 14. And then you can go ahead and type that whole thing into your calculator. So if I were to type this in, I have 25 times 11 minus 0.5, and I just like to change 1/2 to 0.5 because I already know what it is as a decimal, times 11 times 14 equals, and I get 198. And so I get 198 centimeters squared. For number 6, it says an air traffic control tower uses radar to coordinate movement of aircraft to maintain safe distances between them. The radar scope displays a circular region with the control tower at the center. So our control tower is here. And then it says if the maximum distance displayed from the scope is 60 miles from the control tower, which is at the center, what is the area of the region displayed? So we're just doing the area of a circle. And so we've got area equals pi r squared. That's something that we should have known from our previous module, but this is something you should have known for a while now. All right, and so we've got pi times 60 squared. If they ask in terms of pi, what you want to do is just go ahead and put your numbers in first. So we're going to do 60 squared, and that gives me 3,600. And we put that in the front, and then we're going to just leave pi on the end. If they ask for in terms of pi or for an exact answer, that is what you're going to use. If not, and they ask you to round, like in this question, it says round to the nearest tenth. And so we're going to do 3,600 times pi. You make sure you use your pi button unless they tell you not to. And make sure you hit equals. And I get 11,309.73. And then they asked us to round to the nearest tenth. 3 is not going to change that 7, so that's just going to be 11,309.7 miles squared. All right, looking at number 7. It says a circle has an area of 45 square meters. What is the area of a sector when the arc measure is 80 degrees? So we learned that the area of a sector, and I'm going to use A, is the area of the circle times the degrees over 360. This piece here is what you should be adding on to your area and your circumference formula on your formula sheet. That way you can remember for sectors. All right, and so it tells us that the area, which is pi r squared, is 45. I don't even have to do a whole bunch of work. Times 80, which is the degrees of that sector, over 360. So the area of that sector, make sure that you're using your calculator correctly. We have 45 times parentheses 80 divided by 360, close parentheses, and then make sure you hit that equals at the end, and we get 10. So 10 meters squared. All right, number 8. It says find the lateral area of a right-angled triangular prism. So that means that this is 90 degrees and this is 90 degrees. And then we're also finding the surface area. So lateral area and surface area. So surface area is everything. So the top, the bottom, and the sides. Lateral area, lateral means side. And so when they talk about the lateral area, they're talking about everything but the bases. So in some shapes you have 2 bases, and in some shapes you have 1 base. The lateral area is everything but the bases. Your surface area is everything on the sides and the bases together. And when we look at the formula that they give us for a triangular prism, we have SA, which stands for surface area, is equal to 2 times the area of the base plus the perimeter of the base times height. Make sure that you know what the B and the P stand for. B is for area of the base, and then P is the perimeter of the base. When you're looking at these prisms, they're not always going to put the base on the bottom. And so we name a prism by its base. So triangular prism means that the triangle is our base of this particular shape. And when we look at this, this means 2 times the bases. So this is the base areas. And then that means this right here are the side areas or the lateral areas. Okay, so we've got the area of the 2 bases, so base area, plus the lateral area, and that gives us our surface area. So we can kill 2 birds with 1 stone by doing this all together in one thing. So we've got 2 times the area of the base. Well, if this is a triangle, we need the height and the base for our triangle. So I've got a squared plus b squared equals c squared. If you know your Pythagorean triples, you automatically know that this has to be 3. But if you didn't, that's okay. We've got 4 squared plus b squared equals 5 squared. That gives me 16 plus b squared equals 25. And then when we get b squared by itself, that's going to be 9. And then of course that ends up b equals 3. All right, and so 3 is our height for this one. And so for the base of this, or the area for this particular base, it's a triangle. And for a triangle area, not delta or change in A, this is area of the triangle, is equal to 1/2 base times height, which means it's going to be 1/2 of 3 times 4, which is going to be 6. So we've got 2 times 6 plus the perimeter of the base. So that's when we add these 3 together. So the perimeter of our base is going to be 3 plus 4 plus 5, and then times h. Now remember, this is the height of our prism. Because this is the base, this has to be the height. So our height is going to be 11. So now we've got 12 plus, and then 3 plus 4 plus 5 is also 12 times 11, and I get 12 plus 132. And then if I add these together, I'm just going to move this down just a tad, is going to be 144. So my surface area is going to be 144. And then remember, this is our lateral area. So this is the area of all the sides put together. And so that's going to be 132. And then if they asked us for the area of the bases, it would be 12. For number 29, they're asking us for the lateral area and surface area of a pyramid. So same concept as number 8, and we're going to lean on our reference sheet, and it tells us that the surface area is equal to the area of the base plus 1/2 the perimeter of the base times L. And they use two different variables for lateral height. They use H sub S, I believe, and then they also use L. They're both the same thing. So same thing goes with this one. This is the area of the base. And then this right here is going to be your lateral area. And with this one, we only have one base. The only base we have is this down here. Okay, and that's why it looks a little different than our last shape where we had two bases because it was a prism rather than a pyramid. All right, so now from here, it tells us that this is a square pyramid or a regular pyramid. You might see it as either one. So in this particular question, it says square pyramid, but on your reference sheet, it says regular pyramid. And what they mean by regular pyramid is that the base is a regular quadrilateral, and a regular quadrilateral is a square. All right, and so for the area of the base, we know that that's going to be 8 squared or 64. And then we've got plus 1/2 times the perimeter of the base. Well, I know this is 8, this is 8, and this is 8. And so 4 times 8 gives us 32. And this right here is called the lateral height or the slant height. It's not a true height because the true height is like this. It goes down and then it's perpendicular to the base. So the slant height or the height of the side, and it's slanted, that is what we're going to use for L. So L is your slant height. And that is noted on your reference sheet, but you just need to be able to recognize it when you see it on an actual shape. So that's going to be 7. So we've got 64 plus, and then you're going to multiply all of this, and that gives me 1/2 of 32, which is going to be 16. So 0.5 times 32, which is 16, times 7, gives me 112. And that means our lateral area is 112. But then when I add these two together and I get 176, that is going to be our entire area of the whole thing. For number 10, it says, what is the surface area of a sphere with a radius of 9 centimeters? And once again, go back to your reference sheet. The surface area of a sphere is 4 pi r squared. So we've got 4 pi, and then r is equal to 9, so 9 squared. And then, like I said before, go ahead and put in all of your numbers. So we're going to do 4 times 9 squared equals, and I get 324. And then pi. So if they ask for exact answers, this is what you want to give. And be careful because it almost looks like C is our answer. But remember, you're doing 324 times pi. So 324 pi is our exact answer. And if we multiply that by pi equals, I get 1017.87. And that rounds up to D. So just be really, really careful about this. All right, here we go. Number 11. Number 11 says a right regular hexagonal prism has what planes of symmetry? Planes of symmetry is almost like line symmetry. So line symmetry is like how many times can I fold it? or how, where can I fold it to where it's the same on both sides? It's very similar to a plane of symmetry. So a plane of symmetry basically means where can I cut it to where I'm going to end up with two of the same 3D figures. So let's kind of think about where we can cut this. So it says how many are parallel to the base. Well, the base is this top piece, right? And so if I cut it in half here, I end up with the same thing on the top and the same thing on the bottom. And so here it really only has one plane of symmetry going through that centerpiece, because remember, I want to be able to cut it once and both of my pieces need to be the same size and all that. Here we go. Now, how many planes do we have of symmetry perpendicular to the base? So that means we're going to be slicing through the top. So before we were slicing through the side, now we're slicing through the top. And let's think about where we can slice this to where it would be the same. So I could slice it here through the top, and I see how this is the same as this. So that's one of my cuts. I could go kind of diagonal with it, and I could cut here. I could cut here. Okay, so that's 3 just off there. And then I'm going to go to the bottom just to kind of show you what these other ones look like. So, or I'll just go ahead and erase them. So I went through, I'll put them at the bottom. I went here. I kind of did these diagonals where I'm hitting the corners, right? So that's 3. But then I have these rectangle parts, right? Which means I could cut it through here. And remember, a regular hexagon, and I know I'm butchering this. Okay. From here to here, it's like a rectangle piece. Okay, which means I can cut through this rectangle, I can cut through that rectangle part, and then I can cut through this rectangle part. So now I can cut in the middles rather than at the corners. So I have 6 planes of symmetry there where I can cut it and it's going to be the same piece on both sides. Alright, moving on to number 13. Number 12 has been eliminated. So number 13, a certain airline requires that carry-on luggage is designed to fit within a rectangular prism with a length of 24, height of 12, and width of 8. What is the maximum possible volume of a piece of carry-on luggage? That's just a volume of a rectangular prism, and this is something you guys have been doing for a long time. Length times width times height. Not even something I need to remember. And on your reference sheet, they have it as the area of the base times height. Well, that's length times width is the area of your base, and that's where that comes from. So length times width times height is going to be 24 times 8 times 12. And so go ahead and pop that into your calculator, and we end up with 2304. Alright, let's go ahead and move on to number 14. So for number 14, it says a square pyramid. So remember, a square pyramid is the same as a regular pyramid. Has a height with sides, side lengths of 2 feet, and then a height of x plus 3 feet. So I'm just going to go ahead and draw a square pyramid. That way we can kind of get a visual. Doesn't have to be perfect. Okay, kind of looks something like that. All right, and so we've got 2x Okay, and then I know all of these are the same. And then it also gives me the height, so I'm just going to put this off to the side, and the height is x plus 3. So now from here, when I look at my formula sheet, it says volume equals 1/3 times the area of the base times height. And be careful, because this is where you're so used to putting something like 1/2 base times height, and I know I've been guilty of this, and not going back and just checking my reference sheet or checking back to that I wrote on my paper the correct formula. So just make sure that you're really paying attention to spheres and pyramids, that you are putting the correct fraction in the front, and that you're also using the correct exponents when you have formulas with exponents. So always make sure you double check. Always make sure you go back, or when you're showing your work, that you're going back and forth and you're checking and you're writing your formula on your paper before you start plugging in numbers. All right, here we go. So we've got 1/3, and then the base of this pyramid is a square, so I know that's going to be 2x times 2x. So 2x times 2x is going to be 4, and then x squared. And then the height is x plus 3. And then now from here, I'm going to go ahead and do the second half of this, and I'm just going to write it over here. So we've got 4x squared times x plus 3. I'm going to use distributive property, and there's a 1 in front of here, and so 4 times 1 gives me 4, and then I have 3 x's in this rainbow, so that's going to be x to the 3rd power. When you multiply with exponents, make sure you're adding them. So I have 2 plus 1 gives me 3. And then for that second rainbow, 4 times 3 gives me 12. And then I have 2 x's in that rainbow. So now it's 1/3 times 4x cubed plus 12x squared. And then multiplying by 1/3 is the same as dividing by 3. So 4x cubed plus 12x squared divided by 3. I could leave my answer like this. So this would definitely be an acceptable answer. You want to see if you can, if you would be able to simplify these, 4 divided by 3 and then 12 divided by 3. In this case we can't, because 4/3 doesn't simplify, and so we're going to keep this whole thing like that. So this would be an acceptable answer, or you can write these out separately like this: divided by 3 plus 12x squared divided by 3. And in this case, this would simplify. And so another acceptable answer for this would be 4/3 x cubed plus 4x squared. That would also be an acceptable answer. So either one of those would be okay. If you're doing multiple choice or something like that, they'll probably have that on there for you. All right, looking at number 15, it says some ice cream cones have a height of 5 3/4 inches, and then the diameter is 2 1/5 inches. What is the approximate volume of the cups to the nearest 1/10 of a cubic inch? If you want to type this into your calculator, you can. The height for this one is 5.75. To type a mixed number into your calculator, so to do this in your calculator, it's 5 and 3/4. 5 and 3/4, and that would give you 5.75. Same thing for 2 and 1/5. We've got 2 and 1/5 is the same as 2 and 1/5. And that means our diameter is 2.2. All right, here we go. So now for number 15, we're looking for the volume of a cone. And if I look at my reference sheet, that's going to be 1/3 area of the base times height. So I've got 1/3. Now, the area of the base, you need to know that the base is a circle. And so that's going to be pi r squared, and then h, which is 5.75. And then r, we already have our diameter, so r is going to be 1.1. So now I have 1/3 pi 1.1 squared times 5.75. And then just like before, because this is all multiplying, we can just put this in our calculator. Put 1/3 in parentheses, okay? And here we go. So we've got open parentheses 1 divided by 3 times 1.1 squared times 5.75 equals, and then I get this number here, and it's asking us to round, so let's go ahead and multiply that by pi. So times pi equals, and I get 7.285. And then for here, it says round to the nearest tenth, so I want one number behind the decimal. And that's going to be, that 8 is going to change the 2 to a 3, so I have 7.3 inches cubed. For number 16, it says complete the steps to find the volume of a sphere with a radius of 8 centimeters by subtracting the volume of a cone from the volume of a cylinder, each with a radius and height of 8 centimeters, round to the nearest hundredth. So they're basically just breaking this up into multiple pieces. So the first thing we want to do is find the volume of a cylinder. And we know based on our reference sheet in our practice that your volume of your cylinder, I'm just going to draw a picture, is going to be equal to the area of the base times the height. And the base of a cylinder is going to be a circle. So it's going to be pi and then r squared times h. And it tells us that the radius is 8 and the height is also 8. So that's the same thing as 8 cubed pi. Okay. And 8 cubed pi is going to be 8 cubed is 512, and then I'm going to leave pi on there for now. And then we also need to find the volume of the cone. And they told us that the volume of the cone and if I look at my reference sheet, it's 1/3 times the area of the base times the height, just like what we did in number 15. So we've got 1/3, and then the base of that cone is a circle again, and so we've got pi r squared and then times h. And then they told us that the radius and height for this one is also 8 and 8. So we've got 8 squared times 8 again. And so we know that 8 cubed is 512. So that's 1/3 of 512 and then pi. So really, for this, it's going to be 512 pi, or we could go ahead and put that in our calculator and round it. But either way, what they're doing here is 512 pi minus a third of 512 pi. So if you think about what this means, that means that your answer is going to be 2/3 of 512 pi. We're taking the whole 512 and we're minusing a third of it. That means we're going to have 2/3 of 512 pi. And so now we can go ahead and throw all these things in our calculator because they probably want us, it says round to the nearest hundredth. And so let's go ahead and put some of these in our calculator. So we have 512 times pi equals, we get 1608.50 because that 5 is going to change the 9. So 1608.5. Okay, and then we're going to take a third of that. So I'm just going to go ahead and do divided by 3, and we get 536.17. And then if I were to subtract those, I get 1608.5 minus 536.17, and that gives me 1072.33. And if I put that in my calculator, put this, the 2/3 that I got, so 2 divided by 3, parentheses, and then times 512 times pi, notice that I end up getting the exact same thing. So using my exact answers, I end up getting the same thing as when I did each piece and rounded, by the way. And then it says that it's 2 times that. And so that's the formula they gave us. So I've got 1072.33 and then times 2, and I get 2144.66. 2144.66, and then it's already going to be rounded to the nearest hundredth because I've been rounding to the nearest hundredth. And notice that here it says use 3.14 for pi. When I round to the nearest hundredth, it's automatically going to do that for me, but you might want to be careful, especially on questions like this where you have to like write in your answer that you're using that 3.14 instead of pi or instead of your exact answers as you're working. All right, moving on to number 17. It says if triangle ABC and triangle DEF are similar, and the area of a triangle ABC is 31.2 square inches, and then they give this to us. So let's go ahead and draw out these two triangles. It doesn't have to be perfect. A, B, and C, and then D, E, and F. And then these two triangles are similar. It says AB is 4 and then DE is 6, and then the area of this one is 31.2 inches squared. And then it says what is the area of DEF? When we did perimeter, we were only working in one dimension. So we were working with lengths and distance, which is just one dimension. So inches, centimeters, feet, whatever. When we're working with area, we're working with 2 dimensions. So you're still going to almost kind of do what we did before, but you're not going to use the scale factor as is. So let me show you what I mean. So remember to find our scale factor between the two triangles, we did new over original, right? And so that would be 6 over 4. And then if we had something like perimeter, you would just take the perimeter, multiply it by its scale factor, and then you get the new perimeter. But because we're dealing with two different dimensions, so this would be the same as 3 over 2, what you're going to do is you're going to do 31.2 times 3 over 2, which is the scale factor, squared. So for area, you need to do the scale factor squared. And that might be something that you need to add to your reference sheet. And so on your reference sheet for perimeter, you're just going to do your regular scale factor. For area, it's going to be scale factor squared. And then for volume, it's going to be scale factor cubed, because for volume, you're working with 3 different dimensions. And then, so go ahead and throw this into your calculator. And when we throw that into our calculator, that's going to be the same as 31.2 times 9 over 4, and that ends up giving us 70.2. And then that would be inches squared, because it's still in area. All right, and then let's do number 18. So something similar for number 18. We've got 2 cylinders going on here. So I'm just going to draw 2 of them. Doesn't matter how they look. They look kind of wild. All right, and so it has, a cylinder has a volume of 156 and a height of 4. And then there's a similar triangle with a height of 10. And then we're looking for the volume of this one. And so similar, you're going to take your scale factor, which is new over original, and in this case this would be the same as 5 over 2, and then from here you're going to do 156 times 5 over 2 squared. And when you square it, just a quick review on exponents, that's going to be the same as 5 squared over 2 squared. So that's going to be the same as 156 times 25 over 4. And then when we put that into our calculator, you should get 2,437.5. For number 19, these are density problems. I do not want you to overthink these. For this, notice that the question is saying how many elk per square mile. And so we can go ahead and write this as elk over area, because area is square miles, right? So they're saying what is the population density of elk, and then they give us that there are between 2,200 and 3,200 elk in the Rocky Mountain National Park, which has an area of 415. So that means it's going to be somewhere between 2,200 elk over 415 to 3,200 elk in that same area. And then go ahead and just divide these out. So 2200 divided by 415 is 5.3. And then 3200 divided by 415 is 7.71. And I rounded these, by the way. So 5.3 and 7.71. And then for number 20, same thing, pounds per cubic inch. And if we're talking about cubic inches, we must be talking about volume. And so this is going to be pounds over volume. And then they tell us a reinforcing bar, better known as rebar, is a cylindrical steel bar used to reinforce concrete construction. A 10-foot piece of rebar has a diameter of 0.625 inches and weighs 10 pounds. What is the density of the steel in pounds per cubic inch? And so I'm going to go ahead and draw out a little cylinder, nothing too crazy. And they tell us that the diameter is going to be 0.625, and then it's 9 feet. But be careful, this, or 10 feet. Be careful though, because we have something in feet and then we have something in inches. So let's go ahead and get this into inches. So 10 feet times 12 inches gives us 120 inches. And so our height for this cylinder is 120 inches. This is how some of these conversion ones mess people up. Because they don't convert it and they just leave it as 10 and then it gets confused. All right, and then we need to find we have the pounds, so it's going to be 10 pounds, but we need to find the volume. And we know that the volume of a cylinder is the area of the base. So I can go ahead and write this as what we see on our reference sheet. The area of the base times the height. The area of the base is going to be pi r squared and then times h. And they give us the diameter is 0.625. That means our radius is going to be 0.625 divided by 2. So 0.625 divided by 2. And that gives us 0.3125. So we've got pi 0.3125 squared, and then times our height, which is now 120 inches. So be careful, it's not 10, it's 120. And then go ahead and pop all of that into your calculator. So I've got pi times 0.312, pi times, 0.3125 squared, and then times 120 equals, and I get 36.8155, so I'm just going to put all that in. 36.8155. And then let's go ahead and find the density, which is going to be pounds per cubic inch, or pounds per volume. So I get 10 divided by 36.8155 equals, and I get 0.2716. And then it says round to the nearest thousandth. So thousandths is going to be 3 decimal points. That 6 is going to change the 1, and so that's going to be 0.272 pounds per cubic inch. Good luck in studying. I can't stress how much you need to know what's on your reference sheet, but also be conscious of the things that you need to add to your reference sheet and study, and what kind of vocabulary you need to be aware of, like slant height, knowing what a regular polygon is, what an apothem is, things like that. So good luck in studying for your test and for your EOC.